let's look at section formula in 3D space. But before we look at that, let's look at what is meant by internal and external division of a line. Let's say I have a point P and I have a point Q. Now what I have to do is I have to figure out a point R such that the line is divided in the ratio of m is to n. PR is to RQ is equal to m is to n. Okay, now here PQ is given. We have to find R which satisfies this condition. This is called internal division. Yes, because we are finding a point R in between PQ. Okay, now let's take another example. We have P and Q and we have to find a point R beyond Q in such a way that it divides the line in the ratio of m is to n. So here also PR is to RQ should be equal to m is to n. Here also PQ is given and we have to find R. But as you can see, the position of R itself is outside PQ. So this is called external division. Okay, so basically a line is divided and what it does is it forms two sections, right? This is one section and this is another section, right? And this is our R. So that's why it's called section formula. Now let's figure out how to find this R. Let's say P is x1, y1, z1. These are the coordinates of P. Coordinates of Q is x2, y2, z2. We have to find R. Let that be x, y, z. This R divides PQ in the ratio of m is to n. Okay, let's convert this PQR into vector form. So OP, position vector, OP is equal to x1i plus y1j plus z1k. Similarly, for Q, the position vector would be OQ is equal to x2i plus y2j plus z2k. And for the R, the position vector would be OR is equal to xi plus yj plus zk. Now let's look at it from a diagram point of view. We have P, we have Q, right? This is, let's say, O. So this is one vector, this is another vector, this is the resultant vector, and this is the point R. And the R's position vector would be this. Now, we are given that PR by RQ is equal to m by n, which implies NPR is equal to MRQ. Now, PR can be written as, remember, PR can be written as OR vector minus OP vector. This is vector arithmetic, and this RQ can be written as OQ vector minus OR vector. So let's open it up. NOR minus NOP is equal to MOQ minus MOR. Now here what we have to figure out is OR. We have to find position vector of R. So which is nothing but OR. So let's bring OR to the left hand side, and rest let's take it to the other side. Now OR is common, so M plus N OR is equal to MOQ plus NOP, and that M plus N can be taken to the other side by M plus N. Now this is vector form. Let's take it to the Cartesian form. OR can be written as XI plus YJ plus ZK. This is equal to, now, M times OQ, that is position vector of Q, can be written as X2I plus Y2J plus Z2K plus N times OP. OP can be written as X1I plus Y1J plus Z1K. The whole thing divided by M plus N. Okay, let's open it up. Open up the brackets. MX2I plus MY2J plus MZ2K plus NX1I plus NY1J plus NZ1K. The whole thing divided by M plus N. Okay. Now let's bring in I's, J's and K's together. So MX2 plus I and I. MX2 plus NX1I divided by M plus N. Let's take the denominator also separate for each of these. Plus J and J. So MY2 plus NY1 by M plus 1 N times J plus now K. So MZ2 plus NZ1K divided by M plus N. That's the XI plus YJ plus ZK. Now the coordinates of R would be what? Would be MX2 plus NX1 by M plus N, MY2 plus NY1 by M plus N, and finally MZ2 plus NZ1 by M plus N. Now remember, here we took it as internal division, right? R is in the interior of PQ. Now if we have to take it external division, that means PQ is here and R is here, right? And let's say this is O, so this will be like this. Now here the difference would only be here. Here we said OR minus OP, OQ minus OR. Instead of subtracting, we will be adding. Now when you take it forward, what you will end up with would be the coordinates being MX2 minus NX1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n. This is in case of external division, and this will be internal division. Now let's use this formula to arrive at something else. Let's say R divides PQ in the ratio 1:1. Remember, 1:1 means what? That R would be in the center of PQ, the middle of the PQ line. So now let's apply the formula. Since this is internal division, we have to use the formula for internal division. So R would be equal to, now remember m and n are 1, 1. So x2 plus x1, we have to use the internal division formula, divided by m plus n. So 1 plus 1, 2. Okay. y2 plus y1 by 2 and z2 plus z1 by 2. Since here R is at the center of PQ, it is also called midpoint formula. Another case could be where R divides PQ in the ratio k:1. Now in this case, R would be equal to kx1 plus x2 by k plus 1, k y1 plus y2 by k plus 1, and similarly kz1 plus z2 by k plus 1. That is the coordinates in case the ratio is k:2. So that is section formula. I think you got the idea. Enough for today. Bye for now.